Hello everyone, today we're going to be learning about scientific notation. Scientific notation is a shortcut, and in chemistry, who doesn't want to have shortcuts? In this video, we will go over how to convert from standard notation to scientific notation and vice versa, scientific notation back to standard notation. Regular or standard notation is a regular way that we write our numbers, and scientific notation is a shorthanded way of writing either very large numbers or very tiny small numbers. Scientific notation has two products. The first one is a number between 1 and 10, and the second one is always to the power of 10 with an exponent that will tell us how many places we have to move the decimal. When converting large numbers from regular notation to scientific notation, we will have to move the decimal to the left. When moving the decimal to the left, the exponent will be positive. When we're dealing with small numbers and we're converting them from regular notation to scientific notation, we will have to move the decimal to the right. When moving the decimal to the right, exponent will be negative. Now for scientific notation, there are other guidelines. When converting small numbers from scientific notation to regular notation, if exponent is negative, we will have to move the decimals to the left and then add zeros where needed. When converting large numbers from scientific notation to regular notation, if exponent is positive, we will have to move decimal to the right and add zeros where needed. So let's go over some problems. Regular notation to scientific notation. There are 586 quadrillion miles from one end of the Milky Way to the other. Convert miles to scientific notation. So we write our number out, and it's a very large number. Since it's regular notation to scientific notation with a very large number, we will move decimal to the left and place decimal to obtain a number between 1 and 10. So we're going to place the decimal between 5.8 because that's a number that's going to be between 1 and 10. Afterwards, we're going to count number of times decimal is moved. So in this case, our original decimal was over here, and we're going to move our decimal all the way over here between 5 and 8 to make a number that is 5.8, and we move our decimal 17 times. Our exponent is going to be 17. Our exponent is positive since this is a very large number. The final answer is going to be 5.86 times 10 to the 17 miles. Let's do another one. The diameter of a grain of sand is 0.0025 inch. Convert amount of inches to scientific notation. Well, this is a very small number, or smaller than 1. Exponent will be negative, and we're going to move our decimal to the right. So our decimal is over here, and it's going to be placed right here between 2 and 5 to make 2.5. We're going to count number of times decimals move, so 1, 2, 3, and since this number is a small number, the exponent is going to be negative. Our final answer is going to be 2.5 times 10 to the negative third. Now let's move on to scientific notation and regular notation. There are 1.7 times 10 to the 18 molecules of water in a single drop. Convert value to regular notation. Let's take a look at our number. The exponent is positive, therefore we're going to move the decimal to the right 18 times. We're going to start over here, and 18 times to the right, and we're going to add zeros where needed. Therefore, we're going to have this much amount of water molecules in a single drop. Very large number. Let's work on the next one. The length of the shortest wavelength of visible light, in other words violet, is 4.0 times 10 to the negative 7 meters. Convert the value to regular notation. Well, when we write our number out again, we notice that the exponent is negative. Therefore, we would have to move the decimal to the left 7 times. So we're going to start over here, and we're going to go 1, 2, 3, 4, 5, 6, 7 times. Our final answer should be 0.000004 meters. Now it is your turn to do some practice problems. You have two practice problems, one where you're converting from regular notation to scientific notation, and the other one where you're converting from scientific notation to regular notation. Feel free to pause the video, look back at the previous practice problems we did, and after about 10 seconds, you should be able to see the answer. And here you have your actual answers. I hope you have the right answers and that scientific notation is easy, and converting from regular notation to scientific notation is easy, and vice versa, converting from scientific notation to regular notation. As always, this is Ms. Ortega, and I really hope you learned something today and that I have made chemistry as simple as I can. Bye bye. Have a good day.